Hi everyone, my name is John, and in this video, I'm going to discuss sampling designs and types of research data. Let's begin with the concepts of sampling. Population. Population is the total of items about which information is desired. It can be classified into two categories, finite and infinite. The population is said to be finite if it consists of a fixed number of elements so that it is possible to enumerate in its totality. Examples of finite population are the populations of a city, the number of workers in a factory, and etc. An infinite population is that population in which it is theoretically impossible to observe all the elements. In an infinite population, the number of items is infinite. Example of infinite population is the number of stars in the sky. From a practical consideration, we use the term infinite population for a population that cannot be enumerated in a reasonable period of time. Sample. Sample is part of the population that represents the characteristics of the population. Sampling. Sampling is the process of selecting the sample for estimating the population characteristics. In other words, it is the process of obtaining information about an entire population by examining only a part of it. Sampling unit. Sampling unit is the elementary unit or a group of such units which, besides being clearly defined, identifiable, and observable, are convenient for the purpose of sampling. For instance, in a family budget inquiry, usually a family is considered as the sampling unit since it is found to be convenient for sampling and for ascertaining the required information. In a crop survey, a farm or a group of farms owned or operated by a household may be considered as the sampling unit. Sampling frame. Sampling frame is a list containing all sampling units. Sampling frame consists of a list of items from which the sample is to be drawn. Sample survey. An investigation in which elaborate information is collected on a sample basis is known as sample survey. Statistic. Statistic refers to the characteristics of the sample. For example, sample mean, population, and etc. Parameter. Parameter refers to the characteristics of the population. For example, the population mean, proportion, and etc. Target population. A target population is the entire group about which information is desired and conclusions is made. Sampled population. The population which we actually sample is the sampled population. It is also called survey population. Sample design. Sample design refers to the plans and methods to be followed in selecting sample from the target population, and also the estimation technique formula for computing the sample statistics. These statistics are the estimates used to infer the population parameters. Let's now proceed to the purpose of sampling. The basic purpose of sampling is to provide an estimate of the population parameter and to test the hypothesis. Advantages of sampling are: first, it can save time and money. Second, it enables collection of comprehensive data. Third, it enables more accurate measurement as it conducted by trained and experienced investigators. Fourth, sampling remains to be the only way when population contains infinitely many members. And five, in certain situations, sampling is the only way of data collection. For example, in testing the pathological status of blood, the boiling status of water, and etc. And number six, it provides a valid estimation of sampling error. The stages of sampling method. The sampling process compromises several stages. First, you have to define the population. Population must be defined in terms of elements, sampling units, extent, and time. Because there is a very rarely enough time or money to gather information from everyone or everything in a population, the goal becomes finding a representative sample or subset of that population. And once you have defined the population, next is you have to specify the sampling frame. As a remedy, we seek a sampling frame which has the property that we can identify every single element and include any in our sample. The most straightforward type of frame is a list of elements of the population, preferably the entire population, with appropriate contact information. A sampling frame may be a telephone book, a city directory, an employee roster, a listing of all students attending a university, or a list of all possible phone numbers. Third, specifying the sampling unit. A sampling unit is a basic unit that contains a single element or a group of elements of the population to be sampled. The sampling unit selected is often dependent upon the sampling frame. If a relatively complete and accurate listing of elements is available, let's say the register of purchasing agents, one may well want to sample them directly. If no such register is available, one may need to sample companies as the basic sampling unit. Number four, selection of the sampling method. The sampling method outlines the way in which the sample units are to be selected. The choice of the sampling method is influenced by the objectives of the research, availability of financial resources, time constraints, and the nature of the problem to be investigated. All sampling methods can be grouped under two distinct heads, that is, probability and non-probability sampling. Number five, determination of sample size. The sample size calculation depends primarily on the type of sampling designs used. However, for all sampling designs, the estimates for the expected sample characteristics, for example, the mean, the proportion, or the total, um, the desired level of certainty, the level of precision, must be clearly specified in advance. The statement of the precision desired might be made by giving the amount of error that we are willing to tolerate in the resulting estimates. Common levels of precisions are 5% and 10%. Next is specifying the sampling plan. In this step, the specifications and decisions regarding the implementation of the research process are outlined, as the interviewers and their co-workers will be on field duty of the most of the time. A proper specification of sampling plans would make their work easy and they would not have to reverting operational problems. Number seven is selecting the sample. The final step in the sampling process is the actual selection of the sample elements. This requires a substantial amount of office and field work, particularly if personal interviews are involved. Moving on to the basic approaches to sampling. There are two basic approaches to sampling. First, we have the probability sampling, and second, the non-probability sampling. Probability sampling. Probability sampling is also known as random sampling or sampling. In this, sample is taken in such a manner that each and every unit of the population has an equal and positive chance of being selected. In this way, it is ensured that the sample would truly represent the overall population. Probability sampling can be achieved by a random selection of the sample among all the units of the population. The major random sampling procedures are: 1. Simple random sample, 2. Systematic random sample, 3. Stratified random sample, and 4th, cluster or multistage sample. Simple random sampling. For this, each member of the population is numbered. Then, a given size of the sample is drawn with the help of a random number chart. The other way to do this is a lottery. You write all the numbers on a small, uniform pieces of paper, fold the papers, put them in a container, and take out the required lot in a random manner from the container as it is done in the kiddie parties. It is relatively simple to implement, but the final sample may miss out small subgroups. So the disadvantage of this sampling method is that the sample will be free from bias because it's random. However, the disadvantages are: first, it is difficult to obtain; second, due to its very randomness, freak results can sometimes be obtained that are not representative of the population. In addition, these freak results freak results may be difficult to spot. Increasing the sample size is the best way to eradicate this problem. Systematic random sample. It also requires numbering the entire population, and then every nth number, let's say third or fifth or 10th number, as the case may be, is selected to constitute the sample. It is easier and more likely to represent different subgroups. Advantage: it can eliminate other sources of bias. Disadvantage: it can introduce bias where the pattern used for the samples coincides with the pattern in the population. Stratified random sample. So at first, the population is first divided into groups or strata, each of which is homogeneous with respect to the given characteristic feature. From each strata or group, samples are drawn out in random. This is called the stratified random sampling. For example, with respect to the level of socioeconomic status, the population may first be grouped in such a strata as high, middle, low, and very low socioeconomic levels, as per predetermined criteria, and random sample drawn from each group. Cluster or multistage sample. So in some cases, the selection of units may pass through various stages before you finally reach your sample of study. For this, a state, for example, may be divided into districts, districts into blocks, blocks into villages, and villages into identifiable groups of people, and then taking the random or quota sample from each group. For example, is taking a random selection of 3 out of 15 districts of a state, 6 blocks from each selected districts, and 10 villages from each selected block, and 20 households from each selected village, totaling to 3,600 respondents. This design is used for large-scale surveys that are spread over large areas. The disadvantage is that it needs detailed sampling frame for selected clusters only, rather than for the entire target area. There are savings in travel cost and time as well. However, there is a risk of missing on important subgroups and not having complete representation of the target population. Let's now proceed to non-probability sampling. Non-probability sampling is any sampling method where some elements of the population have no chance of selection. These are sometimes referred to as out of coverage or undercovered, or where the probability of selection can't be accurately determined. It involves the selection of elements based on assumptions regarding the population of interest, which forms the criteria for selection. Hence, because the selection of elements is non-random, non-probability sampling does not allow the estimation of sampling errors. Non-probability sampling is a non-random and subjective method of the sampling where the selection of the population elements comprising the sample depends on the personal judgment or the discretion of the sampler. Non-probability sampling includes accidental and convenience or opportunity or availability or haphazard or grab sampling. Second is quota sampling. Third, judgment or subjective or purposive sampling. And fourth is snowball sampling. Inconvenience sampling, also known as grab or accidental sampling, this is a type of non-probability sampling which involves the sample being drawn from that part of the population which is close to hand. That is, a sample population selected because it is readily available and convenient. The researcher using such a sample cannot scientifically make generalizations about the total population from this sample because it would not be representative enough. For example, if the interviewer was to conduct such a survey at the shopping center early in the morning on a given day, the people that she or he could interview would be limited to those given there at that given time, which would not represent the views of other members of the society in such an area if the survey was to be conducted at different times of a day and several times per week. This type of sampling is most useful for pilot testing. The primary problem with availability or convenience sampling is that you can never be certain what population the participants in the study represent. The population is unknown. The method for selecting cases is uh, haphazard, and the cases studied probably don't represent any population you could come up with. Quota sampling. In quota sampling, the population is first segmented into mutually exclusive subgroups, such as in the stratified sampling. Then, judgment is used to select the subjects or units from each segment based on a specified proportion. For example, an interviewer may be told to sample 200 females and 300 males between the age of 45 and 60. In quota sampling, the selection of the sample is non-random. For example, interviewers may be tempted to interview those who look most helpful. The problem is that these samples may be biased because not everyone gets a chance of selection. This random element is its greatest weakness, and quota versus probability has been a matter of controversy for many years. Next is judgmental or purposive sampling, also known as subjective sampling. So in this sampling, the sample is selected with a definite purpose in view, and the choice of the sampling units depends entirely on the discretion and judgment of the investigator. This sampling suffers from drawbacks of favoritism and nepotism, depending upon the beliefs and prejudices of the investigator, and does not give a representative sample of the population. This sampling method is seldom used and cannot be recommended for general use since it is often biased due to element of subjectivity on the part of the investigator. However, if the investigator is experienced and skilled and this sampling is carefully applied, then judgment samples may still yield valuable results. Next, we have the snowball sampling. Snowball sampling is a method in which a researcher identifies one member of some population of interest, speaks to him or her, and then asks that person to identify others in the population that the researcher might speak to. This person is then asked to refer to the researcher to yet another person, and so on. This sampling technique is used against low incidence or rare populations. Sampling is a big problem in this case, as the defined population from which the sample can be drawn is not available. Therefore, the process sampling depends on the chain system of referrals. Although small sample sizes and low cost are clear advantages of snowball sampling, bias is one of its disadvantages. The referral names obtained from those sampled in the initial stages may be similar to those initially sampled. Therefore, the sample may not represent a cross section of the total population. It may also happen that visitors to the site or interviewers may refuse to disclose the names of those whom they know. Now let's proceed to types of research data. Data. Data is a gathered body of facts. It is the central thread of any activity, and understanding the nature of data is most fundamental for proper and effective use of statistical skills. Two broad kinds of data are the qualitative data and the quantitative data. Qualitative data is non-numerical data, and it can be nominal, ordinal, interval, and ratio. So, nominal data are named variables, ordinal data are named plus ordered variables, interval, they are named, they are ordered, and proportionate interval between the variables. Ratio is named, it's ordered, it is proportionate interval. It has an proportionate interval between variables, and it can accommodate absolute zero. So this order are ordered with their increasing accuracy, powerfulness of measurement, precisement, and wide application of statistical techniques. The nominal scale. The nominal scale, it is used to label variables in different classifications and does not imply a quantitative value or order. So, nominal scale examples are gender, political preferences, and place of residence. Ordinal scale. So it is used to represent non-mathematical ideas such as frequency, satisfaction, happiness, a degree of pain, or etc. For example, a semantic differential scale question such as how satisfied are you with our services? 1. Very unsatisfied. 2. Unsatisfied. 3. Neutral. 4. Satisfied. And 5. Very satisfied. Next, we have the interval scale. It's defined as a numeric scale where the order of variables as well as the difference between those variables is known. So interval scale examples are there are situations where attitude scales are considered to be interval scales. Apart from the temperature scale, time is also a very common example of an interval scale as the values are already established, constant, and measurable. Um, Calendar years and time also fall under this category of measurement scales. And last one, we have the ratio scale. It's a variable or measurement scale that that's not only produces the order of the variables but also makes the difference between the known variables along with information about the value of the true zero. So example of a ratio scale is a question about what is your daughter's current height? Is it uh, less than 5 feet, 5 feet 1 inch to 5 feet and 5 inches, 5 feet 6 inches to 6 feet, or more than 6 feet? Or also, question like, what is your weight in kilograms? Is it less than 50 kilograms, 51 to 70 kilograms, 71 to 90 kilograms, 91 to 110 kilograms, or more than 110 kilograms? Quantitative data, on the other hand, is numerical data. Quantitative data can be continuous or discrete. Continuous data are variables that can, in theory, be any value within a certain range. It can be measured. For example, we have height, weight, blood pressure, and cholesterol. Discrete, however, are the variables that can only have certain values, usually whole numbers, and they can be counted. Examples are the number of visits to doctor in last year, number of fractures, and number of children. So that ends my report. Thank you so much for watching. Thank you and have a great day. Bye bye.